All right, so 5.4 notes is that we're going to talk about isosceles and equilateral triangles. Those definitions should sound, or those vocab words should sound familiar. We have mentioned them. We haven't learned many properties about them, but we have learned a couple. So our goal for today is to use and apply properties of isosceles and equilateral triangles. So an isosceles triangle is a triangle with at least two congruent sides. Now, depending on what textbook you look in, there are actually two different definitions for an isosceles triangle. Some textbooks will define it as a triangle with exactly two congruent sides. Some will say at least. I'm going to tell you why I choose to say at least. If the property is for an isosceles triangle and you say at least, it will also work on a triangle, the properties will work on triangles that have three congruent sides. Okay? So I believe that it should be at least two congruent sides, since everything we'll learn about isosceles triangles is also true for equilateral triangles. Equilateral meaning all three sides are the same length. Okay, that's why I choose to use the definition that says at least. So any rule that we learn for isosceles triangle will also apply for an equilateral triangle. Okay, which is why I think every book should really use at least. Okay, so the legs are going to be the congruent sides. And then the base is going to be that third side of the triangle. So we're going to highlight what this will look like. So your legs would then be these two sides that we're going to mark congruent here. And the base would be this third side. And these are the names that we use for the sides of an isosceles triangle. So you either are talking about the legs or the base. Then for the angles, we use these terms, the vertex angle or the base angle. And the vertex angle is the angle formed by the two legs. It's the included angle of the two legs. So the vertex angle is this angle up here that's in between the two legs. The base angles, there are two of them, okay? These are going to be the other two angles. That include the base. So look at your base, and on the ends are going to be your base angles. Now, isosceles triangles have one line of symmetry through the vertex angle. So if I take my straight edge and I look here, which you guys actually have already talked about theorems because we did Unit 6 before Unit 5 that actually used this property. But this is a line of symmetry. Where that isosceles triangle can be folded onto itself. This angle matches that angle, this angle matches this angle matches that angle. What do these two angles have to be if they have to be the same angle? They must be 90 degrees. They must be right angles, or the line of symmetry and the base are perpendicular. Very good. Okay. So we have some theorems about about isosceles triangles. And if you have two sides that are marked congruent, we know that this would be an isosceles triangle. So we could then mark that the angles are also congruent, those base angles. So if you have the legs that are marked congruent, the way that I look for this is I take, and the base angles are across from those legs. Kind of like when we learned about across from the largest angle was the largest side, across from well, if the angles are the same size, or if the sides are the same, then across from them are angles that are the same. Okay. So we're going to label this triangle A, B, C. A, B, C. It's the same triangle, we just rewrote it. If we have legs that are congruent, then we have base angles that are congruent. So we could conclude angle A is congruent to angle C in that diagram. And then the converse of that says that if we have base angles that are congruent, then we could go through and say, well then, we must have legs that are congruent. Because across from those angles are the legs that are congruent. So again, I'm going to label these A, B, C, A, B, C. So you would be able to conclude that side AB is congruent to side CB. And if I have base angles congruent, then I have legs that are congruent. So if you know one, then you know the other. Okay, and it works both ways. If you know base angles are congruent, label the sides congruent. If you have the sides are congruent, label the base angles congruent. Do you guys remember what it's called if you can write a statement with the conditional and the converse and both are true? Go ahead. It's a biconditional statement, yes. So this is actually a biconditional. Because we can say it in both ways, the conditional and the converse, and both are true. All right, flip it over. Next we have the isosceles bisector theorem, which is actually something that we have already used. If we know that we have an isosceles triangle here, and this segment down the middle is bisecting that vertex angle, you know that because of our isosceles triangle has to have that line of symmetry, you know that these are the same. You'll also know that these are the same. And as we mentioned, if these angles are the same, they would have to be right angles. Otherwise, they wouldn't form that straight line that they have to form. So the isosceles bisector theorem says that the angle bisector is perpendicular to the base. So if you bisect that vertex angle, that it's going to be perpendicular to the base. That is just the line of symmetry that we talked about. So we have some examples that we're going to do. And this first one, I know this angle is 63 degrees. I don't know what x is, but I know that these two legs are congruent. What else can I label based on this diagram? Go ahead.
You can label the other base angle as 63 because of the legs are congruent with the base.
Yes. Since these are congruent, the base angles are also congruent. So I know that both of those base angles are 63 degrees. What comes next? Go ahead.
So the sum of the triangle has to be 180. You do 180 subtract by those two.
Yep. So since all three angles of the triangle must add to 180, you can take 180 and subtract the 63 and subtract the 63 and figure out what x has to be. What did we get? 54 degrees. So x is 54 degrees. So we're doing 180 minus the 63. And then minus 63 again, and we end up with 54 degrees. Okay. So there's not a ton of work to show, so I'm going to make sure I show what I did there. Okay, you can write it out like that. You could do 180 minus 63 minus 63 equals 54 degrees, and just that's what you typed into your calculator. So on your homework today, since there's not a ton of work to show, at least show me what you're typing in your calculator in order to get these numbers. Okay. Next one, this one here. What can I label in this diagram? Go ahead.
So congruent angle on the right is 30 degrees.
Yep, so this here is 30 degrees. Okay, then what?
So this has 90.
Okay, so this side here is 90. That works. All right. What else?
The other side is the x. So you start
Oh, you want to label this X? You could label that side X. Those angles are going to be the same. There's two different ways you can go about actually finding X here. You could look at the big triangle, the big picture, or you can look at this triangle right here. There are multiple triangles in this diagram, so you can choose how you want to look at this diagram. If you look at this diagram right here, how do you find X? What are you going to do? You have a 30, you have a 90, you have an X. And what do you know about those three angles? They have to add up to 180. So what do you get for that X? 180, subtract the 30, subtract the 90. 60. Okay, you could do it that way. What if you want to look at this whole picture? This angle's 30, this angle's 30. What does this whole angle have to be here? If this is 30 and that's 30. 120. how do you figure out what x is if the whole thing is 120? Split it in half. Both of those angles have to be the same. So once you know the whole angle is 120, cut it in half, and you have that each of those x's are 60. Do you see how you can look at the big picture or the smaller picture? It doesn't matter. You're going to get 60 either way. So there's different ways to look at this. Okay. All right, so let's talk about equilateral triangles now. Now, equal, we know what equal means, right? To be the same. And lateral means sides. So what this is saying is that you have equal sides or same sides. If you have an equilateral triangle, you have the same sides. So if we have all three sides that are marked the same, then we know that not only do we have all three sides that are marked the same, but what do we actually have? All three angles will also be marked the same. So if we have an equilateral triangle, then we have what we call an equiangular triangle. So if we have equal sides, then we have equal angles. That's what that theorem says. Now if we look at the converse of that, if we're given congruent angles here, then we also know we have congruent sides. It's just the converse. So this one says if we have equiangular triangle, then we know we have actually an equilateral triangle. Equiangular means equal angles. Exactly how it sounds. Okay. One more example, then you guys will have time to work on this assignment. Moving this down. What can I label in this diagram? Now again, this is one of those diagrams that you can look at the big picture or you can zoom in on one of the triangles. Go ahead. X is congruent to Y. So that's the first thing that you see that you can label is X and Y are congruent because of the isosceles triangle there. So you have the congruent legs across from that, across from that. Okay. Very good. What else can you label here? What else can we label? Go ahead. Z has to be a right angle. Oh, you know what? I did something bad. That was actually something a lot of you guys did on your quiz too. I had only used one arc for X and Y, and I don't want to do that because one arc was already used on this angle. So I want to use a different symbol here. Do you see that? Since one arc was used up here, I want to use a double arc down here to show these are the same and these are the same. But I don't know if all four are the same. So I want to use a different mark. Okay. But yes, Z is a right angle so far. Go ahead, Faith.
Y is equal to 50 degrees.
Why?
180 minus 130 is 50.
Yes. So I probably started writing 180. We can actually put the work here. 180 minus 130 equals 50 degrees. So that's where you get your work from there. So Y is 50 degrees. Okay, those are a linear pair, so they have to add up to 180. Okay, go ahead.
And then X would be equal to 50 because X and Y are.
Yes, so that's also 50. So I'm looking for W, X, Y, and Z here. I so far have X, I have Y. What else? Z is labeled, yeah, it's a right angle, so we can label that as 90 degrees. Good. Go ahead. So you're looking at this angle, this triangle over here?
Yeah.
Okay, so the 90 and 50, and you get what? 140, and then what did you do with that? So the 180 minus 140, and you got 40, so W is 40. Very good. Give me like a 1 through 5. I feel like I am getting these isosceles triangles. Okay, cool. So on the next page is your assignment. So I'm going to give you guys some time to work on it. Again, notice there's not, you could probably use a calculator and just give me your answer here. But because I require you have to show work, show me what you're typing into your calculator. Okay? Label on your diagram. Also, you have a pretty tricky one over here. What I would recommend doing is highlighting your parallel lines. Then focus on one transversal at a time, and that will probably help you. Another thing I want to mention is you have lots of triangles in this picture, okay? For instance, many people, for whatever reason, want to ignore the fact that this whole thing is actually one big triangle. On top of that, you have 3 smaller triangles in there. You have another triangle over here. You could look at this as a large triangle here. Okay, so there's lots of triangles in that diagram. What do you know about all triangles? What do you know about the angles in all triangles? They all have to add up to 180. So check all of your angles. Check this triangle. Do all 3 angles add to 180? Look at this triangle. Do all 3 angles add up to 180? Look at this triangle. Do all 3 angles add up to 180? Look at this triangle. Do all 3 angles add up to 180? You're going to have to look at little pictures and big pictures in order to solve all these angles. Okay? But you guys have a little while to work on this, and then we'll do our next set of notes too.